Welcome to Shiksharthi, and today's our topic is Reminders Part 3. If you see my last video on reminders, I started type 1 type of questions which will be in the format of a to the power of n when divided by d, and the major clause here is a and d are co-primes. Then we call it as type 1. So we discussed a few problems on type 1, and I said we will continue with some other questions on type 1 only. So let us see some other questions like 2 to the power of 97 divided by 9 and 2 to the power of 95 divided by 9 are two questions. I like to do it here. Okay. So let us see 2 to the power of 97 divided by 9 and 2 to the power of 95 divided by 9. 9 is very close to one of the two power value. Like 2 power 1 we have 2, 2 power 2 we have 4, 2 power 3 we have 8, 2 power 4 we have 16, 2 power 5 we have 32 and so on. 2 power 3 is 8, which is very close to 9. If you remember my previous video, I said very clearly I should select the number in this which is very close to 9 in the sense plus 1 minus 1 difference. Like 8 and 9 have a difference of 1. Such numbers only are allowed to take. So I should take it in that way. So what I require to do now is, since 8 is very close to 9, I need to convert this numerator in the form of 2 power 3. Now see, both the numbers I'll do at a time. 2 power 97 can be written as 2 power 96 into 2 power 1 divided by 9. Base is same, power should be added. See, 96 plus 1, 97 is what you get here. Again, I can write 2 power 3 whole to the power of, you can say in 3 table that will be 32 times into 2 power 1 divided by 9. And now when I divide them, 8 divided by 9, remainder will be 1. Power k, I should write power as k as one of the properties into 2 divided by 9, the remainder will be 2. My ultimate answer is 2 here. So if you observe here, in this case what happened, my friend, 8 divided by 9, the remainder should be actually 8, but I write it as plus 1 here. Actually it should be given as minus 1. So negative reminders, the role of negative reminders. You see my previous videos, you will find what is negative reminder and all that. When 8 is divided by 9, the remainder will be 8 or can be taken as minus 1. Now you can raise a question why I did not take 8. Imagine I would have taken 8, the things will be, see, 8 divided by 9, 8 as a reminder, power 32 into 2 divided by 9, remainder 2, this is what I'll get as a reminder if I take 8. And surprisingly what I see the same number is coming back. This is 8 to the power of 32 into 2. This again I got 8 to the power of 32 into 2. That is not getting divided at all. If I am not taking this minus 1, I'll never get a possible remainder there. Therefore, I had to take a minus 1. So what is the idea behind negative numbers? Whenever you want to minimize the value of remainder. See, I want to minimize the value of remainder. I finally got 2 as a remainder. So I am minimizing the value of reminders. There is a use of negative reminders. So negative reminders plays major role here in this case. Let us see this case again. I want to convert the given numerator in the form of 2 power 3. So can I write this as 2 to the power of 93 into 2 to the power of 2 divided by 9. This is 93, my friends. Now can be written as 2 to the power of 3 whole to the power of 31 into 4 divided by 9. Now further, 8 divided by 9 minus 1 whole to the power of 31 into 4 divided by 9, you get 4 as a reminder. And since the power is an odd number, see the earlier case what happened, the power was an even number. So minus 1 has become a plus 1 into 2, finally 2. Whereas here, minus 1 to the power of odd number will be minus 1 into 4. My ultimate answer is minus 4. But since my answer cannot be negative, I have to get a possible remainder for 9, which is 0, 1, 2, 3, 4, so on up to 8. So 0 to 8 have to be my answer, not negative. So finally what I do, 9 minus 4, 5 is my ultimate answer here in this case. So please understand the importance of negative reminders. If I would have taken 8 here, 8 to the power of 31 into 4, again my same numerator is coming back if I take 8 as an actual reminder. So minimizing the value of reminders, we opt for negative reminders. Negative reminders is a key player here in this case. Okay. So let us see type 2 questions here, all of you. What is type 2 questions? If you observe the definition of type 1, a to the power of n when divided by d, a and d are co-primes. Here a to the power of n divided by d, and here a and d are not co-primes. If they are not co-primes, you know the other word for co-primes is relative primes. If they are not relative primes, then what I should do? So a and d are not co-primes. For example, if I have a question, find the remainder, okay, and the question is 4 to the power of 96 divided by 6. Now if you see in the position of, I'll write this in the form of a to the power of n upon d. If you recognize what is a and d here, a is 4, d is 6. A is 4 and d is 6. So 4 and 6 are not co-primes. So I can call it as type 2. If you look at a type 1 questions here, 2 and 9 both are co-primes. Here 2 and 9 both are co-primes, and see my previous examples also where a and d are co-primes. That is called type 1. So you need to know how do we differentiate between type 1, type 2, type 3 and what we need to apply at that time. Correct? So here what I do now, I'll try to make them co-primes, 4 and 6 as co-primes. So what I do, see here all of you, the basic step here, I'll take only 4 power 1 into 4 to the power of 95 divided by 6. So I split this, I'll take 1 4 outside, which is sufficient for me to eliminate the common value between them. So between 4 and 6 the common is 2, so I'll eliminate by 2 table. So 4 and 6 both I divided by 2, I got 2 and 3. Now my question is 2 into 4 to the power of 95 divided by 3. Now see 2, 3 co-primes, 4 and 3 both are co-primes. Now I'll go by my regular method, type 1 method. Since they are all co-primes, 2 divided by 3, I am talking about remainder right now for us. So now 2 divided by 3, remainder is 2. 4 divided by 3, remainder is 1 to the power of 95 here. So this will be ultimately what? 2. Now please observe, please understand, this step is very, very crucial and very, very important. The remainder which I got right now is a remainder for this value. Remainder for 2 into 4 to the power of 95 upon 3 value. It is not remainder for the actual question. Actual question is after you cancel by 2, you got this as a remainder. If 2 is not cancelled, then what? So what I should do, for this one I got a remainder 2. After you eliminate the common value of 2, so I should multiply that common value which was eliminated earlier. So now the final answer for this question will be 2 into 2, how much? 4. So 4 is my final answer in this case. Is that clear all of you? So I repeat once again what is exactly happening here. Type 2 question will have a and d some common value. They are not co-primes. So what I do quickly, I'll try to eliminate the common value. I'll try to make everything as co-prime. 2 and 3 are co-prime, 4 and 3 are co-prime. I'll take co-primes and then I'll do the type 1. Since these are co-primes now, I'll do the type 1 procedure. 2 divided by 3, remainder 2. 4 divided by 3, remainder 1 to the power of 95. So ultimately my remainder I got it as 2. Then why should I multiply these two? Because this common 2 was eliminated. I should multiply that common number once again here. So ultimate answer is how much, friends? 4. So this is type 2 questions for us. Okay. Now let us see what is type 3 questions, friends. Type 3 questions are again the same statement. Find the remainder when a to the power of n divided by d, but d is a big value. Big is large value, but not prime. D is a large value but not a prime number. I'll remind you one small example so that you can understand. Suppose I have a number like 876 divided by 28. Will I be good at 28 table? Normally majority of us are not. So what we do, we'll first divide these numbers by 7 and then I'll divide by 4. So what I'm technically doing, I'm trying to divide this number into two parts. 28 I'll not divide by 28 directly, I'll divide by 7 and then I'll divide by 4. So I'll split the divisor value so that my division becomes easy. Now what I did here, if you observe, since 28 is a large number, we divide it into 4 and 7. And also you please observe, these two numbers are co-prime numbers generally. These two numbers are co-prime numbers. So when I'm splitting the number also I need to take care that the pair is a co-prime pair. See, I could have also taken 2 into 14 here, which I'm not opting here for that. Is that clear? So I'm splitting this into two numbers which are co-prime numbers. 4 and 7 have highest common factor as 1. So such numbers. So technically speaking, when the number is big or the divisor is big, we'll try to divide that into two parts. So my question is something like this now. Find the remainder. Example question, friends. Find the remainder when 2 to the power of 156 divided by 105. Now, if you observe two things here. One, 2 and 105 both are co-primes. That's the first thing to observe. Second, this 105 is a bit large number. So what I should do, I should split that 105 into two parts. So what I'll do now, see here. 105, I'll split it as 15 and 7. Will it be fine? 15 and 7 both are co-primes. So when I'm splitting the number, I should make sure that the numbers are co-prime numbers here. Important. Now what I should do, my friend? 2 to the power of 156, I'll divide by 15, and same 2 to the power of 156, I'll also divide by the other number, which is 7. Now 2 is very close to 16. So this number can be written as 2 to the power of 4 whole to the power of 39 divided by 15. Whole to the power of 39. So you can again observe here, 4 into 39 is how much? It's 156. Fair enough? Now 16 divided by 15. What will be the remainder, friends? The remainder will be 1. So I got a remainder as 1. That's one thing. Now this number 7 is very close to 8. 8 means 2 power 3. Now this number I should convert as 2 power 3. So what I can do now, this can be written as 2 power 3 whole to the power of 52 divided by 7. And then 8 divided by 7, remainder 1 to the power of 52, and ultimately the remainder is 1. Now both of them I got remainder as 1. I need to recollect you the LCM models here in this case. See what is happening, please understand. Let us call this total number as a to the power of n, or say some value p. What I am doing here, p when I am dividing by 15, I got remainder 1. Same p when I divide by 7 also I got remainder 1. You can observe, same number when I divided by 15 I got remainder 1. Same number when I divided by 7 also I got remainder 1. In both the cases my remainder is same, 1. If you remember LCM type 1, a number when divided by 15 or 7 leaves the same remainder 1, then the value of p will be k times LCM of 15 comma 7 plus 1 kind of a number. You remember this LCM model 1, right? So I'll apply that now, right now. So p is equals to the number which I am actually taking it as a to the power of n, which I am actually having like 2 to the power of 156. Okay, now that is all represented as p. What is LCM of 15 and 7? Since 15 and 7 both are co-primes, 15 sevens is the LCM, which is 105k plus 1. So what we did, please understand, this step is very crucial to understand. 2 to the power of 156, I have converted in the form of 105. Now why I converted into 105? Because my divisor is 105. So you just understand now from here, it's very simple to observe and understand from this one. Listen all of you. 2 to the power of 156 is now written as 105 into k plus 1 kind of a number upon 105. 2 to the power of 156 is in the form of 105k or some multiple of 105 plus 1 kind of a number. Now divide this. 105 divided by 105 or any multiple of 105 divided by 105, remainder is 0. So here I'll get remainder 0, and 1 divided by 105 is 1. My ultimate remainder here is 1. That's my answer. Okay, all of you? So you can see type 3 question here. Let us see one more question on type 3. Okay, one more question on type 3. The question is, find the remainder when 2 to the power of 3500 divided by 153. Now again you see 2 and 153 both are coprimes. 153 can be written as 17 into 9. 17 9s are 153. I split into two values which are coprime numbers. And why 17 and 9 if you observe? Maybe there is only one choice of 17 and 9, but selectively what I observe, 17 is 2 power 4, close to 2 power 4. 16, 17 is very close to 16. 9 is very close to 2 power 3, 8. So I have good numbers here for dividing. So what I do, my friend, 2 to the power of 3500 I'll divide by 17, and 2 to the power of 3500 I'll divide by 9. So this have to be 2 power 4 value now. So this is 2 power 4 whole to the power of 8 times 32. Then 30 will be 7 times and 5 times you have. Divide by 17. This one, 2 power 3 format. Right now this sum of the digits is 8. This number 3 plus 5 plus 0 plus 0 is not a multiple of 3. So I should make it as multiple of 3. So what I do, this number can be written as 2 to the power of 3498 into 2 power 2 upon 9. Now check this number, all of you. Is this number a multiple of 3? Yes. So it is 2 to the power of, it's 33, that is 11 times, 19 will be 6 times and 6 times. And I'm sorry, this should be taken as 2 to the power of 3 whole to the power of something into 4 divided by 9. Now my main agenda is to get the remainder, friends. 8 divided by 9, remainder is minus 1. So minus 1 to the power of 1166 into 4, ultimate remainder is 4. And this time, like previous example, if you see, I got both as same reminders. So I called it as LCM type 1 model I did. And here what is happening, I got two different reminders. One, I'll get it as, what is the reminder for this case, my friend? Minus 1 to the power of 875. Ultimately it is minus 1, or can be taken as 17 minus 1, 16. I got two different reminders in this case. Okay, so what is the concept here? If you see divisor and reminders, if you see, when the divisor is 17 I got 16, when the divisor is 9 I got 4, and the differences are not same, so I should take LCM type 3 model. And LCM type 3 you will find it in my previous videos. Please observe those and then you try to follow this concept. What does that model says? The model says a number when divided by 17 should leave remainder 16, and same number when I divide by 9 should leave remainder 4. Such number I need to find out. So what I do, my friend, I'll take this as q, and n will be 17q plus 16. So here I'll write this one in the form of 17q plus 16. And if I subtract 4 from this number, it should be exactly divisible by 9. So 17q plus 16 minus 4, 12, divisible by 9 it should be. So for what value of q? If I take q value as 1, this is 29, not divisible by 9. If I take 2, 34 plus 12 is 46, not divisible by 9. If I take 3, 51 and 12, 63 is divisible by 9. So for the value of q is equal to 3, cross check once. 17 3s are 51, 51 plus 12, 63, divisible by 9. So here if I apply q is equal to 3, then n is equal to 17 into 3 plus 16, which is equals to 67. So I got the value which is 67, shortest value. And what is LCM type 3, my friend? LCM type 3 says a to the power of n, or 2500, 3000, 2 to the power of 3500, or the value of n which I have taken here, p, you can call it as p also, is in the form of k times LCM of 15 and 9, sorry, 15 and 9, I beg your pardon, it's 15 and 9 plus least common number 67. Least common number 67. So ultimately my answer is 2 to the power of 3500 is in the form of What is LCM of 15 and 9? 153. So it is 153k plus 67 kind of a number. And final step, when I divide both the numbers by 153, then 153 multiple divided by 153 is 1, or remainder is 0, I'm sorry, plus 67. So ultimate answer is 67 in this case. So that is, sometimes you may have to apply LCM model 1, sometimes you may have to apply LCM model 2, sometimes you may have to apply LCM model 3 also. Depends on situation what I got it here. So I should be good at LCM models also while doing these kind of questions, okay? So keep on practicing these kind of questions on models of your reminders. So we did up to type 1, type 2 and type 3. Please practice up to here, and then we'll proceed with type 4 type of questions, okay, in our next video. Thank you all.